So now we're going to look at multiple events happening one after another, and if they're independent or dependent. So to define these terms, an independent event is if the outcome of one event does not affect the outcome of another. So an example of that would be, say you're flipping a coin 4 times and it turns up heads each time. So what is the probability that the 5th will be heads? Obviously it's not dependent on your last tosses. And another example would be like if you have to write a test in the afternoon, but then you ate a sandwich in the morning, so those two events are unrelated, so independent events. When we're looking at dependent events, sometimes called conditional probability, and that's if the probable outcome of an event depends directly on the outcome of another event. So for example, you have event A, you have event B. So the conditional probability of B is the probability that B occurs given that A has already occurred. Okay, so let's do an example. A coin is flipped and turns up heads. What is the probability that the second flip will turn up heads? So this is an example of an independent event. So the first coin is flipped and turns up heads. That's event A. Event B, the second flip, is it a heads or a tail? So first event has no bearing on the second event, since obviously the coin has no memory. So it's just going to be 50%, or 1 out of 2. Part B, a coin is flipped 4 times and turns up heads each time. What is the probability that the 5th trial will be heads? So again, the coin does not remember if it's flipped heads or tails, so same idea, it's 50%. Okay, so part C, find the probability of tossing 4 heads in a row. First thing is I'm going to define my event. So my event A would be tossing heads. And I'm going to do a tree diagram to figure this out. So okay, first toss is going to be heads or tails. Second toss, heads or tails, heads or tails, so these are all your possible options so far. And then third toss, heads or tails, go one more, yeah. Okay, sorry for the messy tree diagram. So now we have our 4 tosses, and we just want to find the probability of tossing 4 heads in a row. So the path we care about here is 1 head, 2 heads, 3 heads, 4 heads. So that's it. So our probability, sorry, I forgot to label this, not in that color. Make it black, and awesome. Okay, so our probability is NA over NS. So how many ways can we roll 4 heads or toss 4 heads? 1. And how many options do we have in general? So we can count the tails, like the extremities of the tree, or we know we have 4 tosses, and we have 2 options for each toss, so it would just be 2 to the power of 4. So that would be 1 over 16. And so therefore you have 6.25% chance of tossing 4 heads in a row. Example 2. A coin is flipped while a die is rolled. What is the probability of flipping heads and rolling 5 in a single trial? So let's label our events. Event A would be flipping heads. Event B would be rolling 5. So here we have two independent events. First, you're flipping heads, and the result of that is not going to affect the outcome of rolling a 5. Okay, so now we're going to draw a tree diagram to figure out what our probabilities are. So first thing, you're flipping a coin, so it can be heads or tails. Second stage, you're rolling dice. So these are your options. Okay, so first part of the problem, we're going to try to figure out the probability of flipping heads. So that would be this path right here. And to get there, our probability is 50%. So the probability of A and B happening is half. And then the second part of it, we want to figure out where this path will take us. So to get to 5, it's going to be 1 out of 6. Oh, hold on. So we're multiplying them because both events are happening. So we're flipping a coin and rolling a 5, or rolling a dice. And that will give us 1 out of 12, which is approximately
8.3%.
Good. That was a guest appearance from Sammy. So just to summarize, the product rule for independent events. So when we have two events, A and B, the probability of A and B happening is calculated using the product of the probability of A and the probability of B. So now we're going to look at the conditional probability of B, assuming that A has occurred. So that's written as this. So P B dash A. And what this means is for dependent events. So that just means that we're looking at A has already occurred, and we're calculating the probability of B, assuming A has occurred. So the probability of A and B occurring for dependent events is the probability of A times the conditional probability of A and B. So let's do an example. What is the probability of drawing 2 aces in a row from a well-shuffled deck of 52 playing cards? The first drawn card is not replaced. So this example is a case of conditional probability because once we've taken the first ace, we've changed the probability of the deck. So now, because the card is not replaced, the probability has changed for the second, like the first event has changed the outcome for the second event. So we would say the probability of an ace and an ace, and these are dependent events, would be the probability of pulling an ace times the probability of the first ace and the second ace. So what is the probability of selecting an ace from a deck of cards? So we have 4 aces out of 52 cards. And now the second ace would be 3, since one has been already selected, out of 51 cards, since that card has been drawn already. And that comes out to 12 out of 2,652, which reduces to 1 out of 221, and that's approximately 0.45%, which is really low. Let's look at another example of conditional probability. So suppose the school's female soccer team has a history of winning 50% of the games if it plays on rainy days and 60% of the games if it plays on fair days. The weather forecast for the next game day calls for an 80% chance of rain. What is the probability that the team will win the game? Draw a tree diagram. Okay, so what has to happen first? Obviously the weather is going to happen first, and that's going to let us know what are their chances of winning or losing. So the next day calls for rainy or fair forecast. So let's say this is rainy, this is fair. It's 80% chance of rain and 20% chance of fair. So if it rains, they have a 50% chance of winning and 50% chance of losing, obviously. And if it's a fair day, they have a 60% chance of winning and so a 40% chance of losing. So since the question is asking us about the winds, we want to trace that path. So that would be from here to here, or here to here. First case, if it rains, it would be 80% chance of rain and 50% chance of winning if both of those events are happening. And that would give us 40%. In this situation, it would be 20% chance of being fair and 60% chance of winning, which would give us 0.12. And so we want to add up these probabilities because we want to look at what are the chances of winning in total. And so we get 0.52, which is 52%. So now I want to write this out mathematically. So using our form, we would say the probability of winning with rain is 50%. So that's that. The probability of winning with fair weather would be that, 20%. And so the first situation that we have would be the probability of winning with rain would be the probability of rain, which is 0.8, times the probability of winning with rain. And so that's 0.5, so that gives you 0.4. Now looking at the second case, probability of winning with fair weather would be the probability of fair weather times the probability of winning with fair weather. And so this would just be the probability, the total probability of winning. All right, that's it.